Coffee stains and my chains. I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. Lico, beast mode, 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 Lico, beast mode. This is not a main thing, really I'm a coder. Coffee stains and my chains, I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. Lico, beast mode, 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 Lico, beast mode.
Yo, chat, what's up? Okay, we're gonna help somebody out with their Waymo interview, so we're gonna get straight into coding. One sec, I just have to address this. Let me send them over. How did the Amazon OA go? What the hell? God. Resume review? Yo, jump on, go on jamesperalta.com and get a first pass resume review, and then I'll do it after. Because if you do it on jamesperalta.com, it'll help you iterate. Yo, Austin, no way. You just got a phone screen right away like that? How do you... Yo, Austin, we have to get you on the call. How did you fix up the resume? Yo, I'm not even joking. A few people have now messaged me saying, nice. Do you think work-life balance? Who's in here? Alpha in the building. Alpha in the building. Do you think work-life balance is dictated? Yeah, 100%. The more work-life, if you're really good, you can work like 1 hour. Hey Mark, how's it going?
Yeah, hi, hello. You
Hello.
hear me?
What's up? What's up?
Yeah, I'm good. How are you?
I'm good. Tuning in from Poland?
Yeah.
Nice, nice. Where do you live in Poland?
Right now I'm living in Warsaw. Yeah.
Okay, okay. I heard
You're from
Poland,
San Francisco, right?
yeah, I heard Poland making a big comeback, like the economy is booming. I don't
Uh,
know. That's what I've
actually, I'm
seen
not.
some stuff.
Yeah, actually, I'm not expert about this because I recently relocated to Poland, to Warsaw.
Oh,
But
okay.
as I see right now, that here are a lot of empty slots, a lot of positions I can apply. Yeah, and thanks to this situation, I guess that's why I got a chance to be in the interview process at Waymo.
Nice. Yeah.
So
That's cool. I know Waymo loves to hire out of Poland. So yeah. So chat, uh the person that we have on the line has an interview at Waymo, so they hit me up and I said, all right, sure, let's run this. Because I know that they just asked LeetCode. They like to ask LeetCode, so.
Yeah, and I'll have in the near future the first technical rounds there. And as you know, they really love lead code problems, just like Google do.
Yeah.
So
I'm very familiar. I have a few good friends who work in there, but the one here. So let me find some questions.
yeah, and I see you you pass the link to me, right? Okay, first name.
Let me find some good questions. I haven't really set this up.
Yeah, I'm just filling the form in the link you passed me. Yeah, can I have some guidelines? I just log in through the form.
Like so. I'll walk you through everything in a second. Make sure you're not on the chat or on the stream because people might spoil it. The question, they might say the solution because they're gonna debate on it and stuff, and they're gonna help me find a good question. All right.
Okay.
I got some. Wait, so how proficient are you at LeetCode, you think? Should I treat it like an actual Waymo interview?
Actually, to be honest, I have no idea because only recently I started applying for FANG companies, and about the lead code, I started on my own about maybe 6 months ago, just trying to refresh my memory about literally every topic on the lead code. So guess I did pretty good this last 6 months, but we will see, I guess.
Cool. Sounds good. All right, I'm gonna start like a dedicated video. Let me just grab something. We're gonna probably spend an hour, so you're good for the next hour, right?
Yeah.
Just check on my Claude Code instance. It's cooking something up. Wait, let me check. What's up? What's up? Chat, how's everyone doing today? No, I don't have. I tried Fable literally one time, and it burned all my tokens for a simple feature. So. Give me like 2 seconds. I'm just grabbing water.
Yeah.
All right. Hey everyone.
Yeah,
So today, or go ahead.
Yeah, sorry. Yeah, keep going.
Okay, I'll do an intro. I'll do some intros and we'll just get into it. Treat it like a real interview at this point. All right, 3, 2, 1. Hey everyone. So today we have a engineer who's interviewing at Waymo. So you want to quickly introduce yourself?
Yeah, hi everyone. My name is Mark. I'm a newly graduate, I guess. I got my bachelor's degree in software engineering last year, and right now I got a chance to go through the interview process at Waymo, and actually that's the main point why I'm here and we do the live stream right now.
Cool. So what's your proficiency in LeetCode?
it's hard to tell. I started doing LeetCode really hard, maybe about 6 months ago on my
Okay.
own, and right now I have about more than 400 resolved problems on
Wow.
LeetCode. Yeah, at the beginning it was really hard because I need to refresh my memory, and a lot of things was new for me. Even just trivial traversing through the tree was a problem for me, but I guess that I did pretty good
Mhm.
all this time, and yeah, I think we will see how
Yeah.
it's gonna go.
And so how did you grind the lead code? Were you doing multiple questions a day? Did you go pattern by pattern? Or were you just taking on random questions?
Right now it was very spontaneous. I just uh, not right now at the beginning, very spontaneous. I just pick up some random question and try to resolve this. But due to the lack of knowledge, it was really hard for me. And then I decided to change my strategy and try to dip into some specific topic, like I don't know, topological sort, graph theory, sorting, and so on. And it really helps me to gain some basic concepts, basic patterns, which I can use to solve others' problems. And right now, on daily basis, I'm trying to solve at least one problem per day on
Nice.
LeetCode.
Cool.
Yeah,
All right.
and
Yeah.
due to my potential future technical round at Waymo, I just bought the premium LeetCode and trying to filter the questions by the Waymo company.
Nice. You got this. Good luck. We're gonna get straight into it. So in front of you is a interactive code editor. You're gonna be able to run your code. What language do you want to use?
Actually, I'm very convenient with JavaScript, so I'm gonna pick up this one language. And just to clarify, I see on my screen just the button join my interview. Should I press this button?
No, no. This is an interactive code editor, so anything you write here, I could see on my end. You can see this, right?
Sorry, because I
Are you
see
on the coder
only
pad?
just I I joined the link you passed me, and I see just the button join my interview
Yeah,
and
join
the
it.
run
Yep.
button.
Join it, and you should land into a code editor. Left side is the code editor, right side is the program output.
Yeah, and sorry, what should I press?
Where are you stuck right now?
Uh, I just see on the screen in the link you passed me just the button join my interview and
Here,
the run button.
share your
That's it.
screen. Share your screen. Let's just see.
Okay. Yeah, this is the screen.
Yeah, join my interview.
Hmm. Yeah.
Yeah,
Okay.
exactly. So you're there. Okay, perfect. Yeah, you can stop sharing now. Just keep the.
Okay. So I want to switch language to the JavaScript.
All right, so you're gonna go with JavaScript.
Yeah.
Cool. So this is. I'll post in the first question. I think JavaScript is
Yeah.
the syntax, but you're gonna be given a root of a binary tree. Or sorry, I forgot to say that we're gonna try to solve two questions in the span of 50 minutes. So pace yourself accordingly. And I want to get running code going, and I want to hear your thought process, different approaches, and time and space complexity. So we're gonna be given a root of a binary tree. Return the length of the diameter of the tree.
Yeah. Okay. Got it. Yeah. Let me read one more time the question. So okay, again, so the binary chance length. So diameter of the tree is the diameter of binary tree. It's the length of the longest path between unit nodes. This path may or may not pass through the root. Okay, the length of a path between nodes is represented by the number of edges between them. Yeah, I want to come up with an example just to be 100% sure I fully understand the question. So okay, we have some binary tree like this. So the diameter is just the biggest length between two arbitrary nodes, right? So
Exactly.
in this case, it's gonna be I think it's gonna be 2 and 10, and between them, longest path between any two nodes in a tree. So okay, if I got the nodes, if I pick the nodes 2 and 10, we would have the path between them, including these two nodes as well. So the path is gonna be 4, right? Because the path is 2, 3, 4, and 10, right? Correct?
No, the well, what does this look? Let's use angled brackets like this to make it more obvious because it's a binary tree. So this is what you're thinking. This.
Yeah.
So the path would be. Why are you including 2 in the path?
I just was thinking the path is just all the nodes in the path and it's including the 2 itself. So that's why I was thinking about the 4.
Yeah. I let's see. I think that could be a path or 10, 4, 3, and 8. I think it's between. Let me check. Okay, yeah. That is
Yeah.
one path, 2, 3, 4, and 10.
Yeah, another one as well is 10,
What
4,
if we
3,
had
8.
this?
So the diameter of this binary tree, okay, longest path between two arbitrary nodes. So we got 12 also here. So if we start from 10, it's going to be 1, 2, 3, 4, 5. So I guess the answer in this case would be 5 because our longest path would be like this. Yeah. So 10, 4, 3, 8, and 12.
Yep, exactly.
Yeah, okay. So I'm thinking about the DFS approach using this traversal to find the diameter of this tree. Okay. So I think initially we need to have some kind of variable like the max diameter, which we're gonna update in the DFS. We got the new path, which gonna be longer.
Sorry, can you repeat that?
Yeah, I'm talking about that. I think initially we need to have some variable, something like the max diameter, which we're gonna update for the um, in the recursion of DFS. And yeah, this is the DFS. So I guess let's start thinking about the uh, base case and recursion case. Okay, let's see. Initially, let's assume we have something like max diameter, which initially gonna be 0, and I want to try to come up the solution with DFS. So okay, I pass something like node, and if this node is literally nothing, so just return in this case. Yeah, and I think the recursion case should be that we need to. Yeah, let me think. Sorry. So as an example, okay, we start from the root in the DFS. Okay. After that, we need to check if this node is null. If null, we just return the function. All right. And after that, I guess I need to try to come up with a recursion case, and I think I need to run this recursion case on the left and right left subtree and right subtree. The right subtree of 2 is literally nothing, so we just immediately return. And after that, we need to run the recursion on the left subtree of the root. And I think, yeah, maybe I have some sort of idea. I think the main point of the DFS, you need to return the diameter. So when we want to execute the DFS as an example for the left part, it's gonna return the diameter of the left subtree.
Mm-hmm.
Yeah, okay, and let's try to find the diameter of the left subtree and right subtree as well. Yeah, and we did it. We previously already have initialized the max diameter. And we need to update this diameter. I guess it's gonna be just the maximum. I'm sorry.
We can get the diameter to the left, diameter to the right. When that returns, you're gonna take the max.
Yeah, we got the diameter of the left subtree of this current node, diameter of the right subtree of this current node, and I want after this try to update the max diameter, which I'm gonna return. Yeah, let me think again. So I have diameter of the left, diameter of the right, and the max diameter gonna be the sum of these two diameters, and including this current node, so +1, I guess.
Why are you adding 1?
because left is the diameter of the left subtree, the same thing about the right, and one is just the current node.
Mhm. I think you're good to implement. Go ahead and implement.
Yeah, I'm just was thinking, did I miss something or not? Okay, let's try to implement this thing. Yeah. So okay, let's call our function something like max diameter of tree. We pass in this function the root. To that, let's initialize the max diameter variable. Yeah, and I want to implement also the DFS. If it's empty now, just return. Yeah, and after that, we want to find out the max diameter of left and right subtree. Yeah, after that, I want to update the max diameter. Yeah, but I see. I think I already see some troubles in my implementation. Yeah, let me finish it first. So I need to run the DFS on the root. Okay, and I need to return the max diameter after that. Yeah, but I think I see the troubles in this implementation because I'm calling this DFS and I need to return something comprehensible to these variables left and right, and which I still don't do. So I think I need to, in the case when we don't have any node, return the diameter of this like 0. Yeah, and I think at the bottom of the function we also need to return the diameter of this path, including this current node. So it's going to be the maximum of the left and right, I think. So it's going to be like a maximum of the diameter of the left of the maximum diameter of the left subtree and right subtree.
All right, sounds good. Running on some tests.
Okay. There's some button to run the tests, or I need to come up with my own tests.
Come up with your own test.
Okay. So I want to keep it copy paste again the tree. Okay, let's run the test on this tree above the function. So we start from the to right. Okay, we are in the node 2. We need to find out the diameter of the right subtree. There's no any right subtree, so it's going to be 0. Okay, we run this function on the left subtree of the root.
Sure.
Yeah, so we pass. Okay, so we pass the 3 in the DFS, and we want to okay, we pass it 3, right here, and we need recursively to calculate its diameter. So it's going to be the maximum of the left and right. But yeah, as I see, yeah, if we on the test passed the root of 2, yeah, so the right is empty, the left is the left subtree of the 2 is not empty, and the initial diameter of the left subtree going to be just the maximum of the left and right, but we don't include the node itself. So I think my assumption is we need to make +1 right here, because we right here don't include the node itself. So in this case, we calculate recursively the maximum diameter of the left and right and the node itself. And okay, in this case, we need to remove, I think, the one right here. Okay, we pass the 3 right here. After that, we go to the 4. Increment by the 1, it's gonna be the diameter of 2. Go to the 10, the diameter gonna be 3. Okay, and the same thing for the right subtree of the node 3. So the right subtree, the diameter of the right subtree are gonna be 2 as well. Yeah, and after that we need to okay, we have the left 2 and the right 2, so the total gonna be yeah, let me think again. So okay, we pass the node 3. We need to calculate the diameter of the left and right subtree. Okay, we did it. For the node 3, the diameter of the left subtree gonna be 2, and so for the right subtree gonna be 2
I
as
think
well.
let's move on to the next question. Your solution makes sense. I'm gonna move this to the bottom.
Okay.
Good job on that first one. So on this next question, we're gonna be given a network of nodes labeled 1 to n. We're also we're also gonna be given a list of travel times as directed edges between two edges. And we need to figure out the time it takes a signal to propagate through the graph. Here, I'll give a more solid example here. Yeah, so we're gonna be given a network of nodes, and this is directed graph, right? And we're gonna be given edges, and these edges have weight.
Yeah.
And then we will send a signal from the kth node, and we need to return the minimum time it takes for all of the other nodes to receive the signal. If it's impossible, return -1. Does that make sense?
One more time. So we need to return the minimum time to pass the signal to every node, right?
Exactly. Let's go into the drawing so I can make it more concrete. So I'll show you the first one. So we're gonna be given a bunch of nodes. Just like this. One, 2, 3, 4. And then we have a bunch of connections like this. And then each connection will have a weight. 1, 1, 1. Right? And we're going to be given some k. Say a k equal 2. That's the start. You need to tell me how long does it take if we start sending a signal from 2? How long does it take for all other nodes to receive the signal?
Okay, so if we assume that the time to get from the node 2 to the node 1 has a weight just 1 right here.
Yeah, just like 1 second. Yeah, it
So
takes 1
in this
second then.
case, yeah, so in this case, the answer would be 2 because we need 2 seconds to reach the node 5.
Exactly.
Yeah, and can I also assume that all the nodes are connected to each other, so we don't have some node without any edges?
Yeah. And well, there's if we we either return the the amount of time it takes for all nodes to receive the signal, or return -1 if it's impossible.
Got it. Okay. So yeah, in this case, I think we just need to run the Dijkstra algorithm because I see right here the weighted graph, and Dijkstra algorithm gonna answer the question about how many time do I need to reach some specific nodes, and in this case, we're just building the table. Yeah, I think I should try to draw something but I'm not a very big expert to draw right here something. So
It makes sense.
let's
I
see.
think your general approach makes sense.
Yeah, we just need to build just a Dijkstra algorithm.
Okay.
We're building some table about how many times we need to reach the nodes. Initially, we need to allocate this with infinity numbers as an example. After that, we get the nearest node of this, and when we reach the nearest node, we need to update its neighbors with the minimum time to reach these neighbors.
Sounds good. Go ahead and implement.
Okay. Yeah, I assume that as an input, we're gonna give the graph like in adjacency list in the function. So after that, I need to build the table. Let's call this distance. And the nodes marked from 1 to n, right?
Yep.
So we just pass right here the infinity, but we are starting from the node which is marked as k. So right here we already in the node k, so the distance would be 0. Okay, so the first step of this algorithm, we need to get nearest node. So okay, if we don't have the nearest node cannot be the first one, the first case, but if we already have the nearest node, we need to be sure that there's no any others more closest nodes. Okay, I think that's the thing which help us to determine the nearest node. Yeah, and also we need to track the visited nodes. Okay, and in the case when when we can pick up the nearest node, it means that we pass through all the nodes and current equals to the 0. And in this case, I guess we need just to break from this infinity loop. In other case, we need to mark this node as visited. Yeah, and the second step of this algorithm, we need to update its neighbors of the current node. So the new distance to the neighbor gonna be the weight of the current node, yeah, plus the weight of the neighbor. Yeah, let me think.
What are you thinking about right now?
Yeah, I'm just thinking about how we can get the new distance to the neighbor node. Because I need the new distance just to compare with the old distance, and if the new distance is less than old distance, I need to update the table list. Uh,
But can you walk me through your current solution so I can try to understand what you're thinking?
Yeah, should I start from the beginning or the
Yeah,
snippet?
start from the beginning.
Yeah, all right, okay. So initially, I'm going to pass to the function the adjacency list of the graph and the keynote where I'm going to start, right?
Okay.
After that, I need to initialize my table with distances. It's going to be like uh, the key going to be like the node, and the value going to be the distance we need. Not the distance, the time we need to reach this node, right? So
Sure.
initially it's going to be infinity, but
Infinity
we
for
already
everything.
start. Sorry.
Infinity for everything. So if we have like four nodes, they're all gonna be infinity. 0, 1, 2, 3. Or for our case, they all start like this, infinity.
Yeah. But we already start from the node k, right? So we already here, and we need zero time to reach this node,
Yeah.
right? Yeah, and after that, I need to do all these things. So the first part, I need to get the nearest node which I have, and apparently the first iteration is going to be the node k, right? So the nearest node is the current, right? I pass through all the nodes I have. So if I don't have the nearest node, so it means the null. So I need to update the nearest node. It's going to be current equals to I. But if I already have the nearest some node, I need to check if this node is really the closest by this thing. So I need to compare the distances.
Okay, so you set 2 to 0, and then you're looping through. Why are you going from 1 to I minus n? Okay.
I was thinking about this. Actually, I guess I need to loop not from the nodes itself, but for this tuples with the weights itself. Because I guess I need this weight something right here. Anyway, this code, this snippet generally need just to find the nearest node, the nearest unvisited node, which I have right now. So let me try to fix this stuff in the loop. So I need to iterate. I need to iterate 3 times.
Iterate through times.
Or maybe I really do a mistake and I need just to iterate for the nodes. Let me think about this. So, okay, on this case, I need just to find the nearest, the closest node, which I have, the closest unvisited node. On the first iteration, it's going to be k, right? But okay, if I have, okay, on the first iteration, it's going to be k. After that, I mark k as visited. And on the second iteration, I need to find some another node. I'm sorry. I think I need just to
distance. Okay, the distance. What did it always find 0?
Sorry. One
Okay,
time.
go ahead. Trying to figure this out.
I think I think I need I need just to loop through the nodes itself, not the times. I looping from for the nodes and checking if the distance to this node is less the distance to the closest node, and if so, I update the closest node. Okay, but in the case if I didn't find any closest node, it means that all the nodes were visited. So I just break through the loop. Yeah, and yeah, does it sound sane, this first step?
Okay.
Yeah, okay, it was the first step, just to find out the closest node. On the second step, I need to update the neighbors of the closest node, and I have the tuples, the array of tuples times, right? So times it's gonna be the nodes from 2 because it's directly graph, and the weight. So I need to find out the neighbors of the current. Yeah, okay. I need to find out the neighbors of the current node. So I have times. I need to filter this such way. To wait. And if from is equal to the current node. So I have the tuples from to wait. I need to get only the tuples when the from node is equal to the current, and after that I need just to map them to the neighbors. So in this case, I just got the neighbors of the current node. Yeah, and I think I need not only the nodes, but also the weight to the node. So I think I need also the weight, right? And in this case, I got the node and the weight to reach this node. All right. Okay, and I need to try to update the new distance. So the new distance to the node gonna be the distance I need to reach the current node plus the weight to pass from the current node to this node. So it's gonna be the new distance of the neighbor. And in case if the new distance is less than the distance in the table of this node, I need to update this table. Yeah. What do you think? Does it look okay?
Okay, you're looking for every neighbor. After you find like the anchor, you're looking at all the edges and then you're updating the new distance to the distance plus the current weight. If the new distance is less than, okay. And then after,
Yeah, and
okay.
yeah, should I describe this snippet or go?
Yep. I think it generally makes sense.
Okay, but
Let's run it.
yeah, but the task I need to find the minimum time to reach all the nodes. So okay, so I need I already have the table of distances, and I think I just need to find the maximum value in this table, and to be sure that there's no infinity value in this table, because if there's infinity value is in this table, in this case I just need to return -1.
Sorry, can you repeat that?
Yeah, I'm saying that if in this table of distances I have the value infinity, it means I cannot reach some particular node, and it means I need to return -1.
Yeah.
But if there's no any infinity values in the distances, I just need to return the maximum value in this table, and it's going to be the time which I need to reach all the nodes in the directly graph.
Mm-hmm. Makes sense. Yeah, I think generally the solution makes sense. Could you run it through some test case?
Yeah, I think we should open again the drawing or just.
Let's get the code running here.
Okay. Yeah, but actually I need to complete my algorithm because this method right now doesn't return anything. Yeah, should I complete this?
Yep, you can complete it.
Okay. Okay. But I need also to check if there is no infinity value. Yeah, I think that's it. Let's try to test.
So actually, let's walk me through the code. Let's just ensure there's no bugs.
Okay. Yeah, but yeah, okay.
Well, once you're done though, because you said that okay, you're gonna look for if there's a value of infinity, you return -1. Otherwise, you take the max value. Makes sense.
Yeah, exactly.
Okay, walk me through line by line. Let's do one last
Mhm.
class. I have a few minutes left.
Yeah, okay. Initially, I need just build the table of distances where the key is going to be the node and the value going to be the time I need to reach this node. Initially, it's going to be infinity, except the point where we start, the point k, it's going to be 0 in this case. After that, I'm running the loop where I need to do two operations: get nearest node and update its neighbors. Yes. So if I didn't pick up any node, so the current is null, I pick up the node. If
Okay,
the
wait,
current
just take a look at this. There's a bug here.
on the
This
line
while
for
there's bugs in the while loop. Let's give you that small hint because we only have a few minutes left. Just take a closer
okay.
look.
Um, okay, if current is null and
What's wrong with this visited?
visited equals to the new set. Mm,
So when this while loop returns and finishes, will this visited be accurate or will it get reset?
Right, it's gonna be a reset on each iteration.
Is that
Yeah.
what we want?
No, not at all. We need to go out and initialize only once the visited set. Yeah, thanks. Yeah,
About
okay.
this-
And yeah, sorry.
What about this for loop? Have a second look at it.
Yeah, so I iterate through each node. If I don't pick up any node, so current equals to the null, right? I pick up. If current is not null, I need to find the really closest node, and if I node is more closer than the current, so I is the current node, and if I is also not visited.
But what if the first node that we look at is already invisited?
If the first node is
Already invisited, like we can access. So the point of visit is not to visit the same node twice, right?
yeah.
Look over your condition. It looks like you can visit the same node multiple times if current equals null.
Yeah, actually, yes, I see. Yeah, because we initialize with a null and it's equals null, so I need to update. So, okay, let me try to fix this. So if
What's this current equals null for?
this one, it's just yeah, let me try to fix. So if the inode is not visited and distance I is less than distance current, and I guess one more logical end, and current is not equal to the null. So if the node I is not visited, if it's more closer to the it's more closer to the current, and current is not null. But if so I is not visited and I is more closer to the current, but if
Yeah. Okay. We're pretty much at time, so I think we can end it there. How do you feel about that performance? How do you think you did?
Actually, I remember this one problem about the DEXA algorithm, and I don't know why. Maybe because it's a live stream, I got a little bit stressful about this one. But I think at least I can come up with with the first some basic approach how we can figure out to solve this one problem. And I think generally the code maybe has some bugs, but at least the general logic should be correct of this one. Yeah, but unfortunately we out of the time to test this
Yeah.
out. So okay, yeah. And the first problem about the Demeter tree, it was I remember something was on the lead code, yeah, and there I heard that this question was a lot asked at the meta,
Mhm.
but this one about the tree diameter was really tricky.
Nice.
So I think the second task was more closer to me, and I'll do this better than the first one.
Yeah. Honestly, I think you were able to find the solutions out pretty quick and code it. You just need to improve on your pacing. So just getting through the questions a lot faster, coding it out a lot faster. So when you're doing questions, try to time yourself. Try to give yourself only 20 minutes to do the question and just work on pacing, work on speed because that
Yeah,
that was
because
slowing you down. Like you knew what to do, but it took a while to get it written down and you were typing it out a bit slow. And I'm like that too, honestly, because I try to make no mistakes, but you have to time yourself as well.
yeah, actually, I think that's really my weak spot because initially I'm trying to describe my whole thought process, and it took a lot of times because my English is not my first language, and
Yeah.
maybe that's the main reason. Yeah, and I think I should just not go very into the details, just briefly describe the solution and start coding uh, with the thought process loudly. So
Yeah.
okay, yeah, that's
I
completely
would
understand.
say with the Dijkstra's, that's a very common question when I research Waymo. So it's make sure that you have that implementation down in like less than 10 minutes because this one's boilerplate Dijkstra. So the only thing that you have here, or one other suggestion is your solution is a little bit unoptimal because you're not using a heap. So the most optimal solution is to use a heap here. But I know in JavaScript there's no heap.
Yeah,
So you know that about it, or like you know that limitation.
yeah, but on my previous interviews where I need to use priority queue, I just was talking about, let's assume we already have some priority queue and that was enough.
Yeah,
Yeah, but yeah, we can accelerate this approach using the heap. Yeah.
yeah, exactly, exactly. Yeah, that as long as you should state that up front. Otherwise, I would think that you didn't know of a heap.
Mhm.
That makes sense.
Yeah, yeah.
Yeah, and then one other suggestion is when you're drawing, these are just kind of nits, but you came up with the example really good. But when you're drawing the examples of tree, you could use the angled brackets to make the tree easier to visualize instead of using the vertical bar.
Yeah, yeah, that's a good point. Sure.
What else? Yeah, I think you're able to catch the issues with your dry run. You broke it out nicely into recursive case and thought about it on like you broke
Yeah,
into
and
recursive
actually,
case.
I
Yeah.
was a little bit worried about the first question. Do you think that was not really bad? Trying to execute this problem. I mean, I also at the end I was trying to describe the solution, but that solution about the Demeter tree needs some recursive thinking, and it's really a little bit confusing to describe the recursive algorithm. So my question is, should I really trying to describe on the test cases like how we can to on each how we can to execute each recursion function, or
Yeah.
just briefly say, yeah, okay.
I think you did well on that. One thing to mention is one thing to even add more to talk about it better is mention that it's a post order traversal because we receive the like we wait until the left completes and then the right completes and that's what allows us to know the results underneath us and make that decision. So usually when I'm working through these questions, I mention if it's going to be a in order, pre-order, post-order, and then why, instead of just saying general DFS. It's fine to say general DFS, but like mentioning what kind of traversal also like helps clear up a little bit of ambiguity. Are you
Yeah,
familiar with the in order, post order, pre order?
yeah, it is.
This case is it's not that bad, but let's see.
Yeah, and actually, I'm really curious. Is the Dijkstra algorithm is really frequently on the interviews
I've seen it before.
because I was heard that the Dijkstra or A star algorithm were asked really really rarely. So that's why I didn't expect this one problem.
Oh no, it's this is pretty common. This is pretty common. Like boilerplate Dijkstra's, just pretty common.
But I see at Vim or Google they're asking a lot questions about the graph, so it's like the topic
Yeah.
number one.
No, this is. I know some people. I have some insider knowledge on the questions, and this might be this. You should know this. That's all I'll say. But thanks for taking the time out to interview. Just message me, and if you ever want to do it again, I could even ramp it up harder. But
Yeah, thank you too.
Yeah.
It was really cool experience. Yeah, on the live. So like on the real interview, a little bit nervous. So it was
Yeah,
really cool.
no.
Yeah, thank you for your
Good
time.
luck. Like, hopefully you got the nerves out, get the reps in. It's better to
Yeah,
do these and get the nerves out the way, and then go into your interview and do it for the first time.
yeah, it's all about the experience, and it's really good that I can do such things as we do right now. So get some experience, and the next time it would be a much simpler, I think. So that's the point for being here for me.
Yeah. Next time I'll ask some different questions, but I know they like graphs and stuff, so it'll probably be around in that area. But
Yeah. All right. Yeah.
cool. Have you had the chance to use the site for the resume building and the AI coding interview?
Oh, I'm sorry. Right now, not. I'll look a little bit later.
Yeah, try out the AI mock assessment. It's gonna run you through the same type of like interview I did right now. Like I tuned
Yeah,
this
mock
I tuned the
assessment.
system to
It's a
do.
site.
Go ahead.
It's a site with the link you gave me, right?
Yeah,
Right.
just go on jamesperalta.com.
Yeah, it's like your site or just a recommendation.
No, that's my site.
Oh, cool.
Built that thing.
Cool. Yeah, that's great. Yeah, I used to practice with mock interviews with AI on another site. But yeah, okay, I'll try yours. It's
What's the
very
site
interesting.
called? The other one they use.
I used try Exponent app, and they added recently the feature with AI assistant tool. So it's like the interview with AI, and you can just loudly speak about your solution, about your approach, and the AI uh, will think about it and say does it doesn't sound straight or not.
Nice.
And
Okay.
after that, rate by the stars your approach.
Nice. Cool. I'll try that out. Thanks for taking the time out.
Yeah, thank you too. Yeah, thank you for your time.
Yeah. I'll
It
see
was
you.
cool. Yeah, see you. Yeah, bye bye.
Bye. Holy chat, my eyes are burning. MGK, hop in. MFG. Yo, MFG, what's up?
Yo, what's good,
Yo,
bro?
MFG, what's up? What's up? How you doing?
Good, bro. My fault. I had the stream up as well, so I was hearing like both of your voices at
Oh,
once.
okay, no problem. I think we're sounds good on my side. You're good, but
All
maybe
right.
hop off the stream so you don't see hints.
Yeah. I'm doing that right now. And my stream was also a bit delayed, so I
Oh,
didn't
really?
realize you were for me. Yeah, I was
Okay.
still on the part where he's like finishing the thing with the guy.
What the heck? Oh, you're watching or you're waiting.
Yeah, I was waiting, but I didn't realize it was like 4 to 5 minutes delayed.
What the heck? That's so weird.
No. It's just delayed on my end, I
Oh,
think.
because you just like went backwards
Yeah,
or you
probably.
paused it.
Or, like, sometimes when it's lagging, it auto delays, so you can like catch up or something. I don't
I
know.
see. Cool. The I sent you the link. Let's hop. Do you usually use
Alright.
Python?
Yeah. Python.
Okay,
So,
perfect.
yeah.
How's the resume? Did you make some updates?
Yeah, I've been a bit busy since yesterday, but yeah, I've been taking like a lot of like because it's been a while since I've been there. Um, but I've just been like remembering a lot of like metrics and stuff I could use. Yeah, I'm definitely gonna apply all that and then gonna hit you up like towards the middle to the end of the week and let you know.
Sounds good, yeah. We'd like to see the before and after.
Yes, sir. All right.
All right, cool. Sick. No problem, no problem. I'm saying something in chat. Okay, cool. So we're gonna treat this like a quick interview. I'll do an introduction and then we'll get straight into it.
Sounds good.
Actually, what's your proficiency in Leak Code? How good are you?
Yeah, I'm like close to finishing Code 150. I'd say above average, but not like good yet.
Okay.
Yeah. And then I'm like goal is like Fang level or higher, like unicorn and stuff.
Nice.
So yeah.
Let's see. Let me try to find some. So you did like you did the whole Code 150 pretty much?
Not a lot of the hearts, but most of the mediums. Except for like maybe greedy. I don't think I did many greedy. Or linked list. Kind of random. I know you would think like linked list would be one of the first few you do, but
Yeah.
it's kind of annoying, so I just skipped it.
Yeah, I'm just trying to find some good questions. You have to leave it early, right? In like 20, 30 minutes?
No, not in 20. From now, I can be in for like, I think I could do a full 60 minutes on honestly.
Okay.
Yeah.
I have a good question.
Sounds good.
Let's see. Alright, cool. Okay, I'm gonna start this up. Hey everyone, so today I have a student from the University of Minnesota. and he's targeting FANG companies and unicorn companies. Do you want to do a quick introduction of yourself, actually?
Uh, yeah, hello. I'm FGK. Gonna not say full name because it's streaming, but yeah, I'm a student targeting intern roles, and then I hope today goes well.
Nice. How many leak code questions have you done?
I have two accounts. On my current account, I have about 60. On my other account, I think I have 112 or 120. So altogether, little over 150, under 200.
Nice. Okay, cool. So this is gonna be the first question I'm gonna ask you. Actually,
So
I'm just gonna ask you one question, but we can go deep into it.
okay,
But you're gonna be tasked with implementing a file system,
all right.
and the file system will have a class, and it'll initialize. Hold up, this looks bad. Let me fix this. Yeah, this looks a little bit better. So we're gonna initialize a file system, and then it's gonna have. Uh, Let me just make sure. Okay. Then we have string. Okay. Okay. Hold up. 1 second. Greets. Yeah. So we're gonna be implementing a file system. We're gonna be able to initialize an empty file system. We're gonna be able to list a path. We're gonna be able to make a directory, and then we want to be able to add contents to a file, and also read contents from a file. So I mean, there's a lot to this, so don't try to tackle it all at once. But I'll let you go ahead and read the question, and I want to see how you break down this pretty big problem into some steps and get working code ready.
Okay, sounds good. So I'm just gonna write my thought process and how I understand it. So it's a class, and what do you call like the helper or the functions I need in my class are, just to reiterate, read content, um, like returns contents of a file, add content, like insert a file, or update content of a file. Um, what do you mean by so is all of this what I'm highlighting right now? Is that make there like makes directory?
Yeah, this right here makes a directory. So these
Okay,
are
okay.
I'll show you. I'll give you the functions: file system, and then
Yeah, could I get the function signatures? I feel like that
yeah,
would be easier.
make directory, add content.
Yeah, because it's a lot of text just down there.
Yeah,
Okay.
there's one more.
All right. I okay, so the constructor, and then with the constructor, do I get anything, or
No, this just initializes the file system.
okay, okay. Um, and then is there is there a goal with time complexity with every single um function? Do I want to do them all in linear time, or is that is there a constraint?
We'll want to have optimized time and space, like when space in storing the data, and also time in like making directories and adding files to content.
Okay, okay.
Well, we don't want
All
it
right.
to unoptimal.
All right, okay. Okay, sounds good. Um so my first thought of this is there's relations from a file to another file. Like a directory, if I'm not wrong, a directory is a file, right? And
Mm.
then and it's a file with a bunch of files under it, no?
Yeah, directory. Well, a directory is not really file. It's a path.
Oh, okay, okay, okay. It's a path to. Oh, yes,
Or
because
sorry,
you would have like.
a directory is like a folder, and it could have files in it.
Oh, yeah, yeah. So it starts from like home, and then goes to the last thing, and then the last thing is where you're currently at, right? Like
Exactly.
if you're so okay, okay, sounds good. So it sounds like to me like it's a graph problem, and like the relations are nodes. I'm just thinking of like how to like solidify that. Um, I, if I'm not wrong, I believe yeah, like you said, directories are like paths, right? So if I'm gonna
Well,
like
a directory. Sorry, I might have misspoke. A directory and a file are different. A directory holds other directories but can't actually contain content. A file cannot have any directories under it or anything under it. It's pretty much just contains content.
okay, so a file is just like a regular node. Um it's I'm just having a hard time like conceptualizing it fully. Like if I were to draw it right here, um or yeah, so if I have like here, this is home, and then like there's one directory here, another directory there, right? And then this directory would have like nodes, like k nodes, right? And then this one would have like a bunch of nodes, k nodes, or let's say like yeah, k nodes, and then also like maybe another directory, right? Would this be possible? Like, can a directory have children that are nodes and directories as well? Like you said, like directory can
Yeah,
contain
exactly.
directories.
Like just think
Okay.
about it as a regular file system on your computer. You can have
Okay.
more directories there, or you can have files, and those files just simply are just text files. We'll just go for that.
Okay. All right. Then yeah, then I guess this is going to be my representation where like oh, and then um what do you call so a I guess a node technically can have like multiple children here, so it's going to be like uh okay, okay. So then for like actually like listing like the first function, the ls, um we we can we know that the path refers to a file if we can like basically like find a path from home all the way to that file, um and then we can just return the list of that path, uh and then we know that, or actually like how will we know that it refers to a file and or a directory? Like will there be like a marker, or will there be like some uh like special character, for example? Like are we going to use like star or like pound or something to indicate that it's a like, or actually since it's a class, I think we can decide for ourselves, right? Like can we like have like actual markers that we can use? Like we can say, okay, if this child is a directory, um like append it with like a pound. If it's like if it's a file only, append it with like, let's say like a star. Then we know that if it's a pound, like if we come across it, right? If we come across it as a pound, then it can like create new children. But if it's a star, then like we can append it to the path sort of. So
So I'm not understanding. Like, are you thinking about how you're gonna structure a node? I'm not
yeah, I'm
following.
thinking about how I'm gonna structure a node, but also how I'm gonna like create a path here. 'Cause,
I'll give
Um,
you some example. I'll give you an example of the inputs and the outputs.
okay.
This is a simple case. I'll throw the example at the bottom. Like we want it to match a regular file system. So we're gonna use the conventions of a regular file system. So for this
Okay.
one, we create a file system. We list the empty directory. We return nothing. Now we make a directory ABC. Right. Then we could
Yeah.
add contents to a file of ABC. And ABC, we're adding a file called D with hello. Then if we list the root directory, we get A. And then we could read the contents of a file. We get hello. Does that make sense?
Yeah, it sort of makes sense. So for list, it would just be the children of this, like of that specific like marker. For read content to the file. Wait, could you explain why? Oh, actually, no. So you added hello to this directory. So you like, so you traversed up to here, and then you like added hello as a you added the content hello to that file.
Yeah.
Then you just return the value at that. Okay, that makes sense. And then for making the directory, yeah, I understand like these three. It's just this is more like object oriented problems I'm having with like actually making the directory. Um, like so for void make directory, like okay, so let me
Yeah. Take it one by one.
right. Okay, let's see here. So creates the directory specified by path, and then if any parent directories don't exist, create them as well. And then you may assume the target directory does not already exist.
Yeah.
Yeah, okay. So you would like, yeah, so you would when would a parent directory, let me just think about that. When a parent directory like would not exist, would be like, let's see here for maker. So if let's say we only have A, right? So if you only have A and we're trying to like make the directory A, B, and C, we would have to first create B to then create C, right?
Yeah.
We'd have to first create A, B, then to create A, B, and C, right?
Yeah.
So I get that. Then I guess yeah, I guess what we could do is again for make directory at start at the top, like start at the top, then like so I'm sort of thinking of like a breadth first search approach. So start at
Wait, so
the
let's
top
start
directory.
let's start with one. Let's start with one function. How are we gonna make the directory?
Yeah, that's what I'm that's
Okay.
what I'm saying. I'm gonna use a breadth first search approach for actually
Mhm.
making the directory.
So what?
So
How are you gonna structure this file system?
and from line 38 to line 40, I'm gonna like have it where, so instead of that,
Yeah.
it's gonna be
But
like,
more specifically, like what are you gonna create any classes? How are you gonna represent it? Are you gonna create like
oh,
dictionaries,
okay,
classes, etc.?
yeah. So I'm gonna represent it via a adjacency list. So it's gonna be a a note, like a string to list key value mapping. Um, and then
Okay.
and then I'm gonna use that, and then I'm gonna basically maintain that in the constructor. And then for make directory, like I'm gonna basically
Sorry, I'm losing
uh,
you a little bit on that. Or could you maybe write it out onto the code editor so I know, so I can see what
okay,
you're talking about? Yeah,
so
like,
like
or maybe just in the comments. It doesn't need to be fully there. Just write your notes there. So
oh, okay,
yeah,
sounds
because
good.
you said a bunch of stuff, but we need it in on
Yeah,
writing. So
okay. So like if you have a graph at some parent, right? Then um basically we would check like if parent not in graph, we would like we would basically create actual like mapping for that parent. Then and then this is like as we go like so parent in directory, right?
Oh, okay.
So
Let me
if
ask. Let me ask you this. Like, could you show me what the file system would look like after we created ABC?
yeah, so file system would look like this. Um then A
Or more specifically, because you said that you're storing it in like a hash map. Can you show me what it'll look like in the hash map? Because
oh okay,
I know
so
how you want it to look as a
ye-
graph, but
oh okay,
I
okay,
want to
yeah.
see that like your actual representation will turn it into that.
Okay, so it would look like this appended basically, right? Then then A will like the way I want it to be appended or to look like in the um like GCC list will be like that. Then I can have like yeah, so this is how I want it to look like. Would this be right or um
What what if you're at, because I'm thinking when you're traversing, what if you're at some node? You need to know what other nodes you can access from if you're in the middle of the tree. So this adjacency list doesn't give you that. So for example, if I'm at B, I look at my adjacency list, then I'll think that I can get to the root. I can think A, and I could think I could also get to B from there, if that makes sense.
so
Like
like
there's no
okay, so like
concept of where you are in the tree or the graph.
all right,
Does
then
that make sense?
like a uh
So when you're doing a
what do you
traversal, right?
yeah.
So basically when you're doing when you're in the traversal, how do you know who your neighbors are?
Well, you know that like
Like
you
for
know who
example,
you're
if I'm at a specific directory, how do I know who my subdirectories are?
by your children, like your
Okay.
who you yeah.
How do you know that here with how you represented it?
Oh, you know that by like by this like the backslash, right?
Hmm.
Yeah, so okay then I guess if you know it by the backslash, this would be like this, A, B, and then no, right? Would this make more sense then? Like that's how I or
Here,
no.
make a small edge case of maybe let's do make their this and make their ABD, right? So you want to
Yeah.
represent that as A. You want this to be AB, something like this. B and D, right? So this is if we create ABC and ABD,
Yeah.
it should create a tree like this. So what would that look like in your hash map?
Yeah, okay, so this will look like A to B, B to yeah. So are you saying to like sort of like void these basically? And
To
then
B, B
oh
to C.
B, C, and D. right?
Okay, yeah,
Like,
that make more sense.
okay, then I guess for when I'm like making the directory, right? Um, like I'm basically like building. I'm building like yeah. I don't think I would need a traversal for the make directory function then, because I'm just going down like the already found path sort of um of like the path that's already in the uh adjacency list. So I would do like I would do let's say I have some string, right? So I would just do like, or I would do string concatenation and then just keep on like adding like this and like add the like the character, right? Then at the end I should have like I should have A B C, right? Or yeah, A B C. No, I mean ABD. Or I should also have A B and then C. But then now like the question comes like, do I want to like store these as well? Like
Let me store this.
the like oh yeah, okay, so from earlier, right? We said that like so in here the the directory like is the directory not, doesn't the directory like here look like A, or sorry, then here would look like A B.
Sorry, I'm getting lost. We would.
So I'm saying to like the adjacency list that I want, right? Could I could I have it where like could I make like two like I'm thinking of having like two like hash maps sort of, like one for the directories, because I know the like I know I want it split by um backslashes, right? But I also like, yeah, I see the vision for like actually making the directory um for like actually listing the, like, let's see here, because okay, let me assume that I've basically like finished make directory. Would it be okay if I move on to like the other functions and like explain my thinking for those, or
I
would you
mean,
want me to
let's
implement?
implement make the directory. Let's
Okay,
start implementing the class with some of the functions and just put placeholders for the other.
okay, and like it starts with like the home always starts with one slash. So I would have this as like the root, then def make directory, which self, and what do I get anything else past? Oh, the path. Yeah. So I have the path, right? Um, I would have like I would have it split up as like um and then, or actually this is not the string I want to build. Um path list. Uh
We just
Oh, okay. So, garden, so that- um, no, actually, other way around. Ready? Yeah. So this is how I think make directory would look like. Like I would have a path split by the backslash, and then I would build a string um that yeah I would, like build a string that has that gets like a backslash added to every single time, and then at every point the string is a directory uh like like itself. So I would go and add it to the directories hash map.
Let me think about this. Like, why are we adding this forward slash?
Yeah, because I want to split it. I want to split it by the like forward slash, but I also want to okay, so
Like the representation that you showed me from line 68 to 72 is different than what you're implementing, so that's why I'm confused. Because I don't see
because that
slashes at all in the hash map that you showed me in line 68.
well yeah, if you look like where right here. So
Yeah.
if you look over here, if you look from like line 49 to line 52, that's the one I'm going with.
Okay.
So it would yeah, so I would have it like go like this. Yeah. This is the one I'm going with. Or do you want me to go back? Because I feel like this one makes more sense. That way I can actually split it by because that's what all of them like have in common, right? So like if I get sent a path like dash A dash B, then I know I'm just going from A to B.
Hmm.
Yeah. So yeah, does this look good so far then or
Sorry, could you repeat that?
sorry, I said does this look good so far then or
Or okay, yeah, just keep going. It's the solution is a bit confusing, but keep going.
okay. All right. Okay. But yeah, yeah, this would be my like my full make directory then.
Okay. Let's go into adding content to a file.
Okay. So it would be the path and then content. Right? Okay, so I know how to like get or wait, add content. So first I here, I'll get these two right here. Okay, so the file, the like the path, I'll know it doesn't exist uh like what do you call if path not in self dot directories, then okay, then I can do make directory mixture of Then uh yeah. Then now I like create it with the content. So I could have like a content like yeah. So now like directories can have uh automatic like mappings to content. So I can do like what do you call self dot content of this path is just going to be this content. Then I believe for like uh read content from file, I would just return yeah. Uh add content doesn't return anything, right?
Pardon? Yeah.
Um okay, sounds good. So for read content from file, I would like return the self dot content of file path. But I let me just check if there's like okay. For reading content from a file, is it possible that the file doesn't exist or
No, it's always valid.
okay, sounds good.
It's
So
always
I'll just
valid
return
input.
all right, I'll just always return self that content of that path. Then I believe the only one that I would need like um a traversal for then would be the listing. So let's see here. Let me copy this. And then what should I call it? List.
Let's bring this down.
What am I getting?
Let's bring this. Let's bring these down so it's easier to.
Okay. Yeah, I'm like scrolling back and forth. Okay, so okay, I'm only getting the path then. All right. So, and
Yep.
it says so if this path refers to a file, return a list containing only that file's name. So in my representation, let me think. So the path is not okay. So if it doesn't have any content, or if it does have any content, um, I oh okay. This is the part where I need to like differentiate between a file and the directory because so far I didn't need to. That's why like my oh sorry about that. See here. I could like see return list must be sorted in lexicographic order, and then I would need to return the names of all. Let's see. Oh, for I believe there's a edge case I forgot for like their like if the path is like it's like starting, I would return. Um, yeah, and then for add content, I would have to like get see self dot content. No, this sheets this needs to be yeah because it's going to be like content of the path.
What are you thinking?
Yeah, I'm thinking of like how to incorporate like um how to incorporate the backslash is like tell me whether I'm at a directory only,
Yeah.
or if I'm also at a file as well. So I have okay. 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 I think I need to get like the parent of it, right? Like I need to get the parent, and it would be like and the parent would be a list that I can get by like splitting the file path, right? Or wait, so for add content to file, let me bring it all back. Uh, yeah, I can always do this, right? Then like yeah, so I want to like the parent of something. I'm gonna make like a helper, a parent,
Mm-hmm.
just to help me out. Because yeah, okay, so let's see here. Yeah, parent, so right. So um I think I'm basically like reversing the path that I currently have.
Wait, so
Am I
what
wrong?
problem are you trying to fix right now? Like what or what issue did you notice, and then what are you trying to fix right now, specifically for the list path?
Yeah. Well, not even for list path, but to add content to a file, right? Self.content.path. Like earlier, I just had that to be like the content, right? But I don't need it to be just the content, but like I needed to be the content and um like the content of that path. So the content of its like parent as well.
Sorry, not following. Why do you need the parent of the know the parent?
Um, because like if the like okay, if the content was like if the content was like hello, right? And for like let's say the path was like A, B, and right? And the what do you call like the content of this was like let's say uh I would I not and if I wanted A, B, and C, since this is a graph, would I not want to like append this to that? So would I not want to like add high to that or
AB, this is a file.
no, like okay, this is a directory. This is a
Okay.
directory.
Okay.
And then this is the parent directory of this directory,
Yeah.
right? Actually, I'll just go back to my previous idea. I don't think I'm getting anywhere with the parent idea. So I'll just do self.content of that path, and then I'll just set this content, right? Then um okay, then for listing, I'm not really sure then for how to do the listing part.
Okay. Let let's just walk me through this whole algorithm quickly. So we initialize a file with directories and the content. So directories is going to maintain like a hash map from that maintains like a path to what? Like a path to its children?
Yeah, basically.
Path to its
Like
children. Okay. And what's content? Just like a file to contents of the file?
yeah, it's gonna be like a directory, and then yeah, basically.
Okay, let's just like work through a very simple case. We make dir with A and B. Then we make dir with A and C.
Yeah.
So we take the path and we split it.
Yeah.
So we'll get A and B. Right? Or you walk me
Yeah.
through this. You walk through this. Like do like dry run it so you can figure it out. It'll help.
Okay, so yeah, now we have like A and B, right? Then what we're gonna do is like the directories of so okay. So we're gonna have like S start out, right? And then the first directory it's gonna make is gonna be like it's gonna be that A, right?
Like walk
And
through
then
line by line because you're skipping over lines.
okay,
So
okay.
we split
So first
here.
we
Yeah.
split. Now we create like an empty string. And
Yes.
then now we go through the characters in the list that we splitted. We see A. Now we create. Now we add dash plus A to to S, and now S is dash A. Now we see the second letter in our path list. So then now we
No,
add
we do this though. What is this?
yeah. So this adds this is now a directory. Now like this gets added. So for directories, it's going to be like, so dash A, it's going to now point to something, right? But it's going to be an empty
We
thing,
just
but
add.
we just add it as a key. So now later when you're adding contents,
Okay. Well,
uh,
add is for a
and,
set. This is a set. Does this work?
uh,
Can you just add? Like, what's the
or I
key?
could just, yeah, just do S equals that, right? Yeah.
Oh, okay. Actually, directories. Well, I guess you're creating a set here. This creates a set. Oh, okay, you already created a set here. Well, directories is actually a
Oh,
set string. So, like, what is
okay.
set?
I meant it for it to be like this. Sorry.
Okay.
So not hash map, right?
But now you're clearing every directory when you get there.
Well, what do you mean? Like, because like what I'm gonna have in my like directors, it's gonna be like this, right? Then I'm gonna have like A is now
Here, let's not skip through. Let's just go line by line on this
okay.
based on the code because it's getting confusing. Let's just, yeah, let's just start with, okay, you have this. And then now you add S to the directory. So what
Yeah.
happens? Okay,
Right. So
now you
now,
finally get like A. Okay, and then what?
yeah. Right. Then or I could also like yeah, okay,
Keep
then
going.
I'm gonna move on. I'm gonna have now S is gonna be dash A dash B, and then I'm gonna add that as like as a what do you call the like as a node in the adjacency list. Then what I could also do is like what do you call uh basically like I could have like the like last node that we had. So if we had like this, right? So then we can add this as a that way we can like so we can add this to here, right?
Wait,
And I think we
where are we going with this? It's like,
just so we could let's
like you're
see what
modifying.
has
Or I don't know
yeah,
what case you're trying to capture with that. Or,
I'm trying to do like if I have like the last key that we had, right? Be like let this be um right? Then every single time, like what I can check is like if um if last key in self dot directories or actually no, what I could do is like add self dot directories at last key that append this s, right? Then then I could just like move the last key to be s each time, right? Then I'll have like um I'll have or
yeah, this part is getting confusing. I think we need to
this right
take a
here.
step back and simplify things because it should. Yeah, I don't get this part. You have you append to the directories, and then what do we have a last key? I think
I wanted to,
you're not clear on your how you want to represent your directory or your file structure, and it's confusing. You're confusing
okay.
yourself a bit because you're changing the approach on the fly during the dry run.
Yeah, that's true. Yeah, I am.
Like we should figure out the representation up front,
Y-
and you should have a clear understanding of how you want to represent the graph. Because you're right, we want to represent this as a graph. So make sure you have a clear understanding of how you're going to represent the tree, the graphs, the node, or sorry, the nodes and the files, the directories and the files. And then that
Okay.
will help us with how we build it up, given a path.
Okay. Yeah. I think I want to represent it like this where um I have just basic like parent and then child and then parent and then child and then right. I think I want to have it like this. Then um then I think for files,
So for this, where's B or where's C? So we were saying dash A only has dash B. Dash B is
yeah,
empty.
yeah.
Okay.
So for this example where we only have dash A dash B, right? So if okay then I would want like directories to store full directory for full directory paths. Um and or actually no, not full directory paths. It would just be a regular like adjacency list then, right?
Hmm.
Um okay. Is it okay if I delete some of this? Or actually before, like you said, like have the approach like solidified.
Yeah.
Um yeah, then okay then if I have it um if I have the directories hash map as like as basic adjacency like map, then I could um I could have like the content of every like of every like or what do you call it? I could have like the files under every like directory, right?
Yeah.
And then that way I can have like content of that file. So like if I have like files under let's say dash uh, under dash, it would be none, and then files under um, under dash A
Yeah.
would be, let's say, yeah, would
Okay,
also be
so
none.
I'll pause you here because we're at 50 minutes. Damn, it went by fast. I didn't even realize.
Yeah,
Damn.
yeah.
Okay.
I got cooked. Holy.
How do you think? How do you think you did?
I'm like uh a good blacklist. I'm not gonna lie.
No, no, no. I let's see. I think the main thing was just like what you need to improve is your communication and clarity because you overcomplicated the question a lot for me and even yourself. Like
Yeah.
I think you need to just take a step back and when you first get the question, figure out how you want to represent the problem. And you mentioned it's gonna be a graph problem or tree question,
Yeah.
but then you weren't that clear on how you. I don't think you had a clear vision on how you wanted to build out the representation. Like
Okay.
you had it like 60 or 70% of the way, but then you kept changing up your representation to handle edge cases on the fly, and then it was just confusing me which way you're gonna go.
Yeah. Yeah. Makes sense. Makes sense.
So I
Yeah.
think, oh, go ahead.
I think I finally like understood a lot more towards the end, and I actually slowed down. So yeah,
Yeah.
definitely.
So I think changing the, yeah, one thing was you were changing the algorithm on the algorithm approach on the fly a bunch. So
Yeah.
will make things more confusing because I think you're going some way, and then I see you implementing some other way, and then I get confused of where you are at.
Yeah.
So for this one, you could represent it as a hash map, or you could build out the file system using classes, like a class for a directory, and then a class for a file as well. Like doing
Oh,
it
okay.
all in one hash map would get really complicated as well, especially for
See.
like the LS. I
Yeah.
think
Yeah.
also, yeah, you like I could tell that you weren't clear on the representation because you kept asking like, is this okay? Is this okay? And iterating. So I think
Yeah.
when
Yeah.
you go into the interview, you should have an opinion on how to build things because you're the one where I'm asking you to
Yeah.
implement the question. So you should be like, okay, I'm gonna go with this direction, and this is why I think I'm going with that direction.
Okay.
It
All right.
it from my perspective seemed like you were like throwing things out there and then trying to see if it's gonna work with, and then asking me, and then switching your approach. So I think the main thing would just be to improve the communication by coming up with the representations. If it ever gets this complex, then you're probably going down the wrong path. So you really need to take a
Yeah.
step back and try to simplify it and simplify it.
Yeah. Yeah.
Yeah. Try out this question on your own and let me know.
Okay. What's it called?
I gave I simplified it a bit, but it's called design in memory file system.
Okay.
Design. It's a simplified the version that we had. I was gonna give you like a slightly simplified version of that, like a slight variation.
All right. Sounds good. All right.
Cool.
Thanks,
All right.
man.
Yeah,
Yeah.
we'll do this again some other time. Thanks
Yeah.
for
Yeah.
jumping on.
Gonna have to prep. All right. Sounds
Yeah.
good. See
Good luck. All right. See you. Bye. Holy, I'm so tired. Yo, Chad, look at my GitHub history. I've been tweaking out. Like the last 51 contributions on the 24th, 23, 37, 43 on the site. So I'm like my brain is not even working at all right now. If I could, yeah, this is me back in the days, but that was like 2018. Oh yeah, Jay. I know, I'm actually tired. I wish I could. If I was thinking straight, I would have probably been able to understand where he was going, but I'm not thinking straight right now, so we'll do another one. MFGK, we'll do another one for sure. I'm gonna try the AI coding interview on my site for this exact question and see how it works. Give me a quick second. Give me like 5 minutes. Give me 5 minutes. 1000%, Nardo. Yo, Farzan was good. Unfortunately. Let me show y'all a quick. No, the stream's not over. Let me show y'all a quick overview of what the website looks like now. So pretty much, this is we have the roadmap now. So if y'all go through on when y'all land on the site, we're gonna have. Wait, let me record this. So I'll give y'all a quick update on where jamesperalta.com is right now. So when you land, we have on the top navigation, we have learn, teach, practice, and apply. So this is the home page essentially, and you could see a roadmap on how to build your resume. This should link to some articles on actually how to structure your resume for SWE roles, how to make good bullet points, etc. So this will take you down a roadmap of job hunt, data structures, patterns, system design, advanced data structures, advanced patterns. If you just want to browse the courses, you can just I have a library. And then this is if you want to learn stuff. Then I have this teach mode where you teach. This one's interesting where this is a blank slate student where it doesn't know anything about the world of coding. It doesn't know anything about coding, and you have to teach it. So it's gonna ask a lot of dumb questions or just questions that a beginner would ask. So it tries to dig into your learning. So the concept that I'm trying to build out here is you learn by teaching. So this helps you talk through your ideas, and if you give hand wavy explanations, it should try to dig into that and get you to clarify. So this is you can learn traditional way or you can go ahead and teach. And then I have the practice. These are AI interviews, as in I'll show you a simple one, like get kicked into twosome. You'll get thrown into an interviewer or you'll get thrown into an interview where you'll have to talk through like your approach and then code and then feedback. And it's pretty much an AI agent that's trained to run an interview or conduct the interview the same way that I would conduct interviews. So you choose your language, then you'll start it. I'll show a demo of that later. So with Peralta 75, you'll do like one question at a time and there's no time limit. But if you want to test yourself for an actual interview, then we have the actual mock assessments here. This will run you through 2 questions and you pretty much have an hour to solve both questions, and it will make you run the interview the same exact way that I was running the interview, or I run the interview on the channel. So I think between these, I just finished implementing system design and behavioral interviews. It's hidden right now, but that's gonna go live soon. And then also I added like a full application tracker, so you can track all your applications. You can create some drafts, and you can work with the resume coach to tailor your resume. So you can build out your resume, and then lots of people have tried this already. I think in the last few days I had 90 resumes created. So this one's working. This is my best AI agent so far. It's working pretty good. Had some good feedback on it. And I'm distilling all the learnings that I had from building this AI agent into all the other agents to make them better. But this is pretty much the best agent that I have so far. And then, yeah, you can pretty much start an application and then move it and manage your, like, track your applications here as well. So what I'm trying to solve here is applying for jobs end to end. So all in one platform, you should be able to build your resume, learn new skills, and practice and stuff like that. So yeah, that's pretty much it. Let me know if you have any feedback. I'm gonna try out that same exact question, but with the AI interviewer. So let's see how it works. Why did I take the role demotion is because they gave me the same amount of pay. So honestly, I don't even care about the role, the position. I just care more about the pay. So they gave me even more pay, and it's all cash. And when I interviewed at Meta, I only had 4 years of experience. So when I did the interview, I did well on the interview, and then they just told me that, I mean, you lack the experience to, usually for an interview, it requires 6 years if you're transferring in. But like if you're in the company, you'll move up faster. But if you're transferring in, they love to down level. Yeah, they love to down level. They love to down level. Like when it's easier to go to a senior if you're at one specific company and move up. But if you're trying to transfer companies, usually they're gonna down level you. If you only have 4 years of experience and you're trying to go for senior, there's a good chance they're gonna down level you. And when I was interviewing with them, I even had a little bit less than 4. It was like 3.5, 3 years and like 10 months or something. Because I stayed at my first company for only 3 months. Oh yeah, I stayed at my first company for only 3 years. Then I switched. And then when I switched, let's just look at my resume. So I stayed at my first company for 3 months, or 3 years, then I switched. And when I switched to the Rippling, I did good in the interview, so they gave me a senior offer. So I was pretty much a senior with at the time when I got the offer, I only had like two less than 3 years of experience when I got the senior offer. So I was already hyped about that, and the pay was really good. And then I started interviewing. I started at Meta at May, but I got the offer like 6 months. Yeah, they like to inflate, honestly though. But Rippling's a different startup. All the other if you look at the other seniors there, they all had like 10 years of experience. They'll like to down level as well. But essentially, when I applied to Meta, I only had like 2.5 or 3.5 years of experience because I only started at June. So with like 3.5 years of experience, like you can't just switch to a fan company and get senior with 3.5 years of experience. And honestly, like that was fine. I actually didn't care. Well, honestly, startup it really depends. Who Yeah, I got the top of the mid level. Yeah, exactly. But also it doesn't really matter about the title. It more matters about the pay. So if you get a senior offer and you're getting paid a mid-level salary, then it's inflated. But if you're getting a senior offer and you're getting senior pay, then is it really inflated? The reason why companies like to inflate titles sometimes is because they don't want to pay you. They want you to be happy that you're a senior, but they're really paying you like less. So like, oh, you're a senior, but then they're paying you what other intermediates get at other companies. So that's what I would call like inflation, right? Exactly. But when I got offer at senior, they're giving me literally senior pay. So I didn't feel like it's inflated because they're giving me pretty much what other seniors would get or more at other companies. So I didn't think it was inflated. I'll show y'all something. See if I'm getting doxxed. Dox myself. This was like the offer. Check this out. But it's funny, they're talking about like your comp if it 10x, 5x, 3x, or 2x. But this was like way back. So they don't show stuff like they changed up the offer. I don't even know if they don't structure it the same way like that no more. Yeah, the base is high, right? Or was the comps doing that? Yeah, the equity is just straight paper. But alpha, I mean, I thought it was straight paper, but when I moved to my current company, they told me that they treated it like it was actual money when I was negotiating. So But they said it really depends on the company you're at. Or it really, yeah, if they think that the company is definitely gonna make it, then they just treat it like cash. Holy, I remember. Yeah, that's crazy. What was the hardest part of the interview process? It's not honestly, if you did enough leak code, it's not that hard. I would say the hardest part for most people would probably be the system design because it's just not something you get used to, or it's something you just need to get used to. But other than that, um, that's part of it. Yeah, system design is probably easier than lead code, I would say. But like you can catch someone BSing. Take your time. Let's read the problem and restate the task in your own words. Design a data structure that simulates an in-memory file system. A file system initialize the object. If a path is a file path, return the list that only contains this. Yeah, exactly. Honestly, I'm not gonna. Ever since the start of the year, I feel like it really changed this year when I started doing more. When I stopped relying. Okay, so introvert, no clock. Take your time. Just read the problem and restate the task in your own words. So we're given a file system. What the heck is this? Let me just make sure I understand how I'm gonna explain it. Let me just give a hand wavy explanation and see if it understand. Yeah, so we're basically just building a file system like on your computer. You can list a file path, you can make directories, and then you could also have files. So you can have files, directories, you could read files and then also add elements to files. Bro, I hate how it does this though. I don't know if I'm a fan of this. Now give me one tiny example of your own. I'm still trying to figure out how I want the experience to be. Sometimes I'll name the operation order and see what the file system contain after each one. I guess it wants me to dry run. Alright, so on line 34, I'm going to start writing my own example. So use two. So saying write one example, don't not just the intent to do so. Use 2 to 3 operations. Say what the file system state is after each one. This is kind of actually this is similar to what I was doing with the last candidate, where I was just like come up with a small example. So I think So I think one example is we're gonna have file system, right? And then we're going to make directory, and then add contents. Read content. And then ls is like later. So for my example, let's try to trip this thing out a little bit. All right, I have an example there on line 34 to 40. So we have a make directory path. So for this, let's just do a simple case when we call A, B. A, B, A, C. So what do we have to return here? Okay, this returns none. This returns none. And then we can create A, B, C. Hello. You fixed up your resume a bit? Okay, send me. Nice. Yeah, I'm getting good feedback on this resume agent. People actually like that one. So I'm trying to make all my other agents just as good as that, but it's not going to be easy. So if we read the content of A, B, C, we get back hello. Then what do we do? Okay. What if we do if path is a file path, return a list that contains only this file's name. If path is directory, return the list of the file, and directory names in this. Okay. So if we ls a, we get B and C. Bro, where are you working? Okay, I have an example now on line 36 to 41. I think I'm hitting all of the correct cases, or like all of the methods that you mentioned. So first we initialize the file system. Then we make the directory A and B and create all of the directories in that path. Or we're given the path A and B and we create all the directories in that path and there's no return value. Then we make the directory for A and C. A already exists, so we don't need to create anything. But then we'll need to create the new directory for C. Now, when we add the content, or I guess there's a mistake there. When we add the content for A and C, we're adding, or sorry, go A. Yeah, when we add the content to the file, we're adding to A, B, we're adding D, and we're adding the content hello in there, and that returns none. And then after we read the content from the file, and then we could also and then line 41 we could just list a specific directory. This is a hard level question on LeetCode, so it's gonna be. Oh, I like this because it's saying I want one clean example, not the general behavior. Pick 2 or 3 exact operation, name exact. I thought that's what I did though. Resulting state. Yeah, this is a. Let me test the agent on like TwoSum or something. Oh, it's too much. Let me check it on TwoSum. Doing some agent testing. Read and restate the task in your own word. Given an array of integers nums and an integer target, return indices of 2 numbers such that they add up to a target. You may assume that each input would have exactly one solution, and you may not use the same element twice. Return the answer in any order. So for this question, yeah, we're gonna be given an array of numbers, and we just want to find 2 indices that add up to some target, and then we want to return those 2 indices. That's the gist of the task. Okay, see if I can pass this now. Yeah, if you teach your robot on my site, it should get better. Should get better, ideally. Yeah, right now it doesn't know anything. So we're gonna be given nums and a target. Result equals, so if these are 0, 0, 1, 2, 3, 4. So for this one, we'd probably want to return 2 and 4. So I have an example there on line 25 to 28. I I created some array with a target of 8. And that should return 2 and 4 because those are the indices. The index 2 has 5 there, and the index 4 has 3. And if you add those up, you get the target of 8. What should happen if two numbers are at the same value? What should happen if the two numbers are at the same value but different indices, or if one of the numbers is negative? What? I mean, it doesn't really matter if two numbers are the same value, because we just need to find two numbers that add up to each other. So it needs to be distinct indices. We can't reuse the same indice twice. And also, negative numbers doesn't really matter as well. The only actual edge case we need to care about is if there's no two indices that actually add up to the target. You see? No, you really have to explain your solution in order to let it pass. Trust me, it's not easy to pass this AI interviewer. No, it really wants you. It's trained to really make you say exactly what you think and don't have a hand wavy solution. Look, it kind of gave me away the you. Kind of get a hint. Yo, like, let me. I need to add that feedback. What the heck? Gave away the solution. Yo, JN, you should try out this agent and let me know. I need feedback. Gave away the solution. I mean, there's multiple approaches on this. Were you able to pass it, JN? So there's multiple approaches. How was the experience? Yo, JN, let's hop on a call soon. Let's hop on, I need user feedback ASAP. What's your email? Or send me an email again. I need some user feedback. If you're free. Send me an email so I can get user feedback after I finish this. Yeah, so there's multiple approaches. The naive approach would just be like a double for loop, and that leads to an O of n squared solution. But we don't need to have a double for loop. There's also an O of n approach. We just keep track of the other values that we've seen before. Because if we know the other values that we've seen before and we know the current value, there's only one number. Like, if we know all the numbers that we've seen before and we're at a current number, we just need to know like the difference between me and the target. And if we've seen that other number before, like to our left, we could just return that. And the way that we can search for the numbers we've seen before really fast is using a hash map. I mean, I just told you why it works, but we have a time and space complexity. Or the time and space is be O(n) time, O(n) space. Let's see if it lets me pass without explaining why it was O(n) time and O(n) space. Oh, it says go ahead and implement it in the editor. Alpha, I don't even know what I don't know what exactly my vision for it is, but I'm just trying to I just want the AI. I'm just trying to train the AI to behave like an actual interview. You know what I mean? But it's hard to make it because without live transcription, it doesn't have live transcription, so it doesn't know what I'm saying in real time, and it doesn't know what I'm like. It doesn't see what I'm doing on this all the time. You know what I mean? So it has to really only know what I say to it and then the current state of my code. But maybe as I make edits and stuff, it can capture the deltas so it kind of knows what I'm doing as well. Okay, let's try to trip it out. Okay, looks like my solution is working. How's that look? Yeah, that's the plan. That's the plan. Yeah, exactly. Alpha, like what I'm trying to do here is capture not just the final solution, but the thought process. So I want to be able to capture like somebody's thought process in like while they do the AI or while they do the interview. So that's but I want to be able to do it asynchronously, like capture their thought process. And then if when I provide like coaching services or anything, I'll be able to easily understand where their thinking breaks down. Because most platforms you kind of just jump straight to the solution. I just use OBS. Okay, I'll show my solution. Um, I'll just implement it. Yeah, Alpha, this is mostly for students and stuff who are actually trying to learn, and so I mean they could try to jump to the solution, but I don't think it'd be. I would advise them not to. Target minus none. Mm. Like Alpha, this is I want to eventually make it teach harder and harder things like competitive programming and stuff like that, but we need to start with the basics because I eventually want to just turn it into. I want it to coach me, so that's kind of what it's where it's going. I mean, so what we're doing, we're saying scene. No, I haven't covered system design and behavioral interviews, but I'm working on that right now. But once I have like agents for system design, coding, behavioral, resume, and like one that you can teach. Another, what's up? Then I'm just gonna spend a lot of time making sure that those agents work. I don't want to increase the scope. I want to just go deeper into those. I think those core agents, and then just figure out the best way and just keep learning how to build like a good agent. And then from there, expand it. But I think yeah, I'm missing the I'm missing the system design. I'll give you all a quick preview of that, what that actually looks like. Oh shit. I'll show you all a quick one. Sec. So we have system design and behavioral interviews coming through soon. So this one. So this one, I'm still working through how the UI is gonna look, but you should be able to like the AI should be able to see what you're doing. You can build like connections between them, stuff like that, and then we'll iron out that experience, and then behavioral interviews like still working through this, but the way that I'm implementing this is the way that just like based on my experience of how these actually get ran. So it's going to be very opinionated on everything. But these are going to go live once I figure out the agents. But yeah, what do y'all think? Try to copy the robot's message from right bottom to top left. Okay, yeah, we'll talk about it in a sec. See, I need to get user feedback. Oh, okay, it's all good. It's all good. Okay. Looks good to me. All of the tests are passing. Oh, it didn't even clarify. Honestly, I think I did pretty well. No real. Figured out the optimal solution. Came up with a test case. Yeah, that's pretty much it. Yeah, communication skills is a lot of it. Okay, you handled the core problem well. You identified the right data structure, got to the expected linear scan, and your example shows you understand the goal. The main thing I tighten up is your communication under interview conditions. There's a brief mismatch where you said the code was done before it was visible. In a real interview, I'd want you to clear. Oh, so it was saying that I was trying to trip it up. I want you to clearly show the implementation and then verify it with a run. The good news is that the algorithm choice and reasoning were solid. The next step is mostly polish. Be a little bit more explicit about what you're storing and make sure your code names are clean and your final explanation is crisp. Yo, I couldn't pass one of those. I couldn't pass my own assessment on one of them. So funny. Can't exit out. Oh, you can't back out. Yo, Empower, have you tried it out yet? Tried out the platform? I'm gonna try one of these mock assessments. Chat, people are not passing my mock assessment. Damn, I'll try this out later. I need to touch some grass today. What's everyone doing today? What's everyone doing today? I actually need to rest up a little bit. My neck hurts. Yeah, hopefully it helps. Nice. You like the... Is there any features that you would like to have there? Did you see the roadmap? Yeah, I pretty much copied roadmap SH. Not gonna lie. Should kick into the articles. I'm gonna spend some time improving all these articles too. I gotta read them over and make sure that they're accurate. And been a while. Empower, what else did you try out? Maybe a library of actual job descriptions for... okay, Empower, I'll show you a secret feature. I'll show you a very secret feature. So if I say find me sweet rolls in OpenAI, it's gonna consult a recruiting agent. The recruiting agent is pretty much like if you place a recruiter. If you place a recruiter in OpenAI, it's gonna search for all the roles. So now we just hydrated the context with some good roles. Give me sweet rolls. I want full stack roles or just any suite. I'm gonna have to add rag here to make this better. I scrape the data, and then it just looks in a database. I don't know if I have rag database though. Okay, I think I need to figure out. I need to improve the search a bit. But if you click on these, it should be links here. Okay, look, it found some. This is most honestly, it only scrapes OpenAI and Anthropic right now because I just want to iron out the flow. But if you message me, I'll figure out stuff for you. But look, it says best full stack matches here. Give me the job description for Nah, I'm enjoying it right now. I'm honestly enjoying it right now. It's not too bad. So it's a product engineering role focused end-to-end ownership of current or emerging products, partnering with product design teams and research to turn model capabilities into user-facing experiences across cloud AI. It emphasizes strong full stack. So once you load this up, chat, you should be able to. It can now check your resume against those. I can tell you which of your current resume best match. Which bullet points? Okay. How does my resume match up against this posting? Yo, W, thank you, thank you. So you're a solid fit for the senior software engineer full stack. Your strongest match are Cloud Code plugin. Where you're weaker is in explicitly showing full stack signals. The posting cares about polished UI product work, accessibility, and direct front end. You do have some of that, but they're not the story lead. Okay, I need to talk more about. So this one, I probably need to align it more with, since it's full stack, talking about the front end related work that I've done and like the product facing. I talked more about some of the platform. So that's actually solid advice. So instead of talking, so it wants me to highlight more of my product full stack instead of infrastructure. Okay. Yeah, that's sort of how it works. I still need to, the more that people use it, the more we're gonna figure out how to make it better. I still need to debug a few things, but all right, chat. I think I'm out for the day. Thanks for tuning in. I'll catch y'all on the next stream. Peace.
This is not my main thing, really, I'm a cold. colder. Coffee stains and in my chains, I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. Lico, beast mode, 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 Lico, beast mode. This is not my main thing, really I'm a coder. Coffee stains and in my chains, I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. Lico, beast mode, 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 Lico, beast mode.